Imagine you're looking at the night sky and suddenly realize that everything you see no longer exists. The stars, the galaxies, maybe they died a long time ago. We are literally living in the past. But then the question is, how much of what we see now has already disappeared? And is there a chance that the next dead spot in the sky could be the sun? You might not like these facts, and they could radically change your point of view.
There are facts that we've known for sure since school. Wind is the movement of the atmosphere. The moon is smaller than the Earth. Everest is the highest mountain on our planet. Along with them, there are concepts that are more in the realm of science fiction, although they are potentially possible. For example, there are rumors that somewhere there are countries that have defeated corruption. And don't argue. Just because you haven't seen them doesn't mean such countries don't exist. They say, speaking of reality, it's also appropriate to mention as an example, time portals, wormholes, or mole tunnels. Do they exist? If they do, in what forms?
Hubble.
In the minds of ordinary people, a portal looks something like this. Space suddenly distorts, and a body or object passing through the anomaly is transported to a completely different world. This visual image is used by creators in many games and movies. This way of transitioning to another reality is convenient and fast, but no one has managed to create something like this in real life yet, which doesn't stop us from thinking about this interesting topic. So what is a portal? The word comes from the Latin porta, meaning gate. Essentially, it's an entrance to other locations, an alternative reality. After thinking about it a bit, it turns out it's not that complicated. Remember, since childhood, we've been surrounded by game rules and conditions that we easily adapt to. Take, for example, jumping over imaginary lava, playing blind man's buff, soccer, or dominoes. Children grow up and the rules change. Now, at work, in court, or on public transport, we behave as the rules of the adult world require. But childhood hasn't gone anywhere. It just moved, taking a corner in the soul of a grown person, showing itself through a passion for books, movies, and virtual worlds. A gamer's feelings are genuine when a flower withers on an imaginary flower bed they've nurtured for half a year. A player also gets very upset when their favorite game character dies. But none of this exists in reality. What is this phenomenon about? Nothing special is happening. It's just our own imagination playing with us. This effect is described in many psychological works, but it is explained especially clearly in Frank Rose's book, The Art of Immersion. A former game designer conducted an experiment in which he asked two subjects to imagine a certain scene, let's say a beach. The person with memory impairments imagined a very impoverished reality, and the healthy person imagined the full spectrum of classic beach imagery, with palm trees, white sand, the sea, and seagulls. This is a landmark test for understanding that our life consists of the gradual layering of memories and experiences. Based on this, a person can adapt to imagined conditions, adapt to any reality, and even construct their own. This is what game developers base their work on, where people take on the role of creators and arbiters of their characters' destinies. Such projects can easily be called mini portals to other worlds, which we take for granted, not noticing anything remarkable about them. When you play, you feel the illusion of control over the situation, even though you understand that the process has been programmed in advance by someone else. Humanity has always been drawn to immersing itself in fictional realities. This explains the popularity of book plots and the demand for epic movie masterpieces that describe entire universes, such as Star Wars or Guardians of the Galaxy. But there is also another side of the coin. Not only do we enter that reality, but it also invisibly seeps into our world. Rapidly developing technologies accelerate this process. Recently, the Oculus Rift virtual reality headset was introduced, allowing you to walk the busy streets of London without leaving your home, see your favorite character up close, or transform your room to your own taste. Even ordinary televisions have become several orders of magnitude faster and more realistic at immersing their owners into imaginary worlds. It turns out that while we search for wormholes, gazing into the depths of airless space, the universal portal is right next to us. It's the World Wide Web. Thanks to the web, you can get an education, read books, watch movies, and learn new skills, all without leaving your own couch. Modern society consumes hundreds of times more information than it did 100 years ago, and there's nothing to be afraid of. It's also not surprising that some people are upset about the dominance of the internet, since similar precedents have already occurred in history. For example, in the 1940s, a handful of angry Americans passionately burned comic books, fully convinced that what they were doing was right. What will be the next step in immersing ourselves in other worlds? If we recall Stephen Hawking, who suffered from a severe illness but still led a rather active intellectual life, we can assume that uploading human consciousness into an immortal artificial body will soon stop being science fiction. Perhaps an intermediate step toward achieving this global goal will be the synchronization of human feelings and emotions with computer processes. Imagine opening your eyes and seeing majestic Jupiter or lunar craters in front of you, and all of it looks absolutely natural. Moreover, you can interact with this reality, move through imaginary locations, build structures, extract resources, and so on. The process of mutual assimilation of both worlds, real and virtual, cannot be stopped. We ourselves, without noticing it, associate video game, book, and movie characters with real ones. We study their biographies in detail. We remember the date when Anakin Skywalker turned to the dark side and became Darth Vader. We know by heart the feats accomplished by Superman or Don Quixote. Many have also become familiar with the biographies of real people. Albert Einstein, by the way, we covered his biography a few episodes ago, or Miguel Cervantes. It turns out that we are well informed about both groups of characters. We discuss the details of their behavior and debate about it. Now think about this. Neither Einstein nor Darth Vader have we seen in person, but it wouldn't be hard to find a biography of either one. Moreover, the biographies of some fictional characters are much more widespread than those of real people. So ask yourself, why are you so sure that Darth Vader didn't really exist? Because you haven't met him in person? But have you seen Einstein with your own eyes? Let's make it a bit more complicated and ask this question. In your opinion, is the Hubble channel real? You regularly watch our videos, but it's just a code, a set of zeros and ones. If you damage the given sequence, the picture will turn into this. You can subscribe for updates and support us with likes, but you'll never be completely sure that there's a real team behind the creation of these videos. That your channel gets attention. Our channel is another portal through which you enter a different reality every day. Enjoy. We wish you pleasant virtual journeys.
Republic of Congo is...
Everywhere we turn, they're scaring us with cataclysms of all kinds. And they claim that the Earth, as the cradle of humanity, is literally on its last legs. But we suggest not to panic, and instead pay attention to the other planets of the solar system, which, besides our own, form a whole family. Credit where it's due to Earth's astronomers. All this time, they haven't been sitting idly by, but have been actively trying to study our neighboring planets using modern equipment and probes. And gradually, they even managed to reach the insanely distant and hazy Uranus. But you'll say it's a gas giant without a solid surface to land on, and besides, it's completely frozen. So what? As the hero of a famous movie once said, there are no obstacles for patriots. Let's take a look at Uranus through the eyes of Voyager 2. the only probe that has visited the planet's vicinity. So what is this bluish, constantly lying on its side, frozen gas giant like? This world is as different from ours as a basketball is from a sea urchin. Uranus is extremely cold. If you tried to live there, you would have to endure temperatures of minus 224 degrees Celsius. And you would also have to get used to the fact that there would never be any ground beneath your feet. It would be like living among the clouds. The states of matter here have no clear boundaries. Gas gradually transforms into liquid, and then, in turn, becomes something similar to a solid. On the planet, everywhere smells of hydrogen sulfide and ammonia like rotten eggs and urine. Uranus is 60 times larger than Earth. Here, winds blow at a speed of 824 kilometers per hour. And there are almost constant thunderstorms, which could outdo all the ones on Earth combined. This place isn't for everyone. It's definitely an acquired taste. Add to that a 42-year-long winter and other seasons of the same duration. No wonder the planet was ignored for so long, right? But in 1986, a NASA probe called Voyager 2 did fly by Uranus. And although the visit was just a flyby and the encounter was rather brief, the probe managed to photograph the Uranus system, along with its rings and closest moons. False color image of Uranus. The outer ring of Uranus. Miranda, Uranian moon. Colors of Uranus. True color on the left and false color views of Uranus. January 17, 1986. Distance 5.7 million miles. 3 moons. 3 moons discovered by Voyager 2, 1986, U1, 1986 U3, and 1986 U4. January 18, 1986. Distance 4.8 million miles. Oberon. The best image of Oberon shows craters and a large peak on the lower limb of the moon. January 24, 1986. Distance 410,000 miles. Ring system. The rear view shows a continuous distribution of small particles throughout the entire ring system. January 24, 1986. Radius of 147,000 miles. When project manager Edward Stone summed up the interim results of the mission, he said that no probe had ever seen a more unusual system. Scientists were especially amazed by the so-called magnetic tail discovered by Voyager 2 at the ice giant, and also the landscapes of Miranda, one of the planet's closest moons. From the probe's photos, it was clear that, for unknown reasons, an incredible mixing of different worlds occurred on the Uranian moon. Martian valleys and channels, the deepest Mercurian faults, Ganymede's trenches, and monstrous lunar craters. At least 10 types of terrain have merged here. Also, among other things, the spacecraft analyzed in passing Uranus's atmosphere discovered 2 new rings and 10 previously unknown moons. As they say, it did everything it had time to do. But why hasn't any other spacecraft visited the giant since then? The unfortunate situation happened for the same reason as with distant Neptune. The destination is incredibly far away. First of all, with our current level of technology, a flight to Uranus would take at least 15 years and would involve multiple gravitational maneuvers. Secondly, no solar panel will work at a distance of 3 billion kilometers, since Uranus orbits 20 times farther from the Sun than Earth does. That means we would have to use a nuclear power source, which is much more complicated and expensive. The next problem is adequate data transmission. After all, there's no point in sending an expensive and lengthy expedition that will send back photos to Earth with last century quality. Therefore, it makes perfect sense to consider equipping the Uranian station with a huge antenna and building a gigantic receiver on Earth. And the last challenge is the team of specialists overseeing the flight. After all, during this time, the number of staff members could easily decrease. And we haven't even started discussing the equipment for the probe yet. In short, the task ahead is extremely difficult, but achievable. Now, the main question: why are these incredible efforts necessary other than to understand the principles of the formation of ice giants and their systems? But there are reasons, and they are compelling. The first is the extraction of valuable resources, and the second is the possible colonization of the planet. Yes, you heard that right. A celestial body without a surface can be settled by human colonies. So, let's start with helium-3 extraction factories, an element found in abundance in the atmosphere of Uranus. How can this plan be implemented? First of all, a base should be built on one of the moons. Then, it is necessary to send an army of remotely controlled robots to Uranus, which will pump atmospheric streams, filter them, run them through centrifuges, and liquefy them. To carry out the process, most likely a drifting base will be created, powered by fusion fuel and located directly in the Uranian atmosphere. Considering the escape velocity on Uranus, which is the lowest among all the giants, transporting cargo will surely not be problematic. But no matter how many robots we use, it is unlikely that such a production could be deployed and launched without human involvement. Therefore, the question of organizing colonies naturally arises. But where can this idea be realized except on satellites? After all, there is no surface on Uranus. It's elementary, right there in the atmosphere. For example, if you fill huge balloons with hydrogen, they could keep entire cities afloat, and the gravity here would be similar to Earth's. To carry out even a part of these ambitious plans, at least one more mission in this direction needs to be launched first. NASA has been talking about such a project for a long time, but because it's expensive and still unfinished, it keeps getting delayed. Meanwhile, the next launch window for a flight to Uranus is between 2030 and 2034. Under these conditions, the trip will take about 12 years. But if everything that's planned comes to fruition, the world can expect a whole bunch of sensational discoveries. This can be said for sure, since the Uranus system is one of the most unexplored locations. In April 2021, it was 31 years since the launch of the Hubble Space Telescope mission. This orbital observatory has become extremely significant for the entire scientific community. The telescope was not specifically designed to study our planetary system, but despite this, we have received many images of celestial bodies located near Earth. In addition, Hubble has captured several amazing phenomena that researchers still do not understand. Most people think that all the most interesting things are outside the solar system. Meanwhile, quite a few amazing celestial bodies are located not far from us at all. Do you want to see unique images of solar system objects taken by Hubble? Then, as Yuri Gagarin said, let's go. Let's start with the comet Shoemaker-Levy 9 and its catastrophic encounter with Jupiter. You've probably heard the gas giant's humorous nickname at some point. It's often called the vacuum cleaner of the solar system. There's actually some truth to this because Jupiter's mass is so great that its strong gravitational pull inevitably affects objects nearby. Moreover, if it weren't for this sluggish giant, mass extinctions on Earth would happen much more often because asteroids would be falling onto our planet almost constantly. So, in 1994, the Shoemaker-Levy comet passed close to the giant celestial body, and as a result, Jupiter literally pulled the object into its gravitational embrace, first tearing it into several pieces. Thanks to the Galileo probe and the Hubble telescope, we were able to witness this amazing phenomenon. It is remarkable that before colliding with Jupiter, the Shoemaker-Levy comet was actively orbiting around it. At the moment when the distance between the objects critically decreased, the comet was moving at a speed of 60 kilometers per second, and it had no choice but to crash into the gas giant. The collision produced gigantic flashes with a temperature of about 23,000 degrees Celsius. Subsequently, the gas cloud rose to about 3,000 kilometers and was even observed from Earth. A huge terracotta ring on Jupiter, 12,000 kilometers wide, formed after a powerful impact from one of the comet's fragments. Scientists suggest that the explosion released energy equivalent to 6 million megatons of TNT. This is hundreds of times greater than Earth's nuclear arsenal. The global scientific community has images of other collisions, but none of them drew as much attention as the final encounter between Jupiter and the comet Shoemaker-Levy 9. Mars and Phobos. The red planet has often been the subject of observations by the Hubble telescope. That's why we have enough information about the Martian surface. Hubble delivered data to Earth that couldn't be obtained from other spacecraft. If you look closely at the following photos, you'll notice dust storms on the surface of Mars, and also how the seasons change on this planet. Such information is very important because it will help predict weather conditions in the future. In addition, the data obtained is taken into account by astronomers when sending rovers to Mars. In this image, you can see how a powerful dust storm has covered the surface of the red planet with a dense layer. In the image, you can also see both of Mars's moons, Phobos and Deimos. Scientists note the rather high speed of these celestial bodies, which allows them to cover vast distances quite quickly. Phobos is the only moon in our planetary system that completes an orbit around its parent planet faster than a Martian day lasts. Next, let's talk about the asteroid 6478 Gold. In terms of its external characteristics, it more closely resembles a comet. In particular, the object has two visible tails. But this fact doesn't make it a comet. You can see a picture of this asteroid, which scientists obtained just a few years ago. It is assumed that the rotation speed of 6478 Gault is constantly increasing. Also, with the help of the Yorp effect, the asteroid could be observed during its disintegration. The essence of the effect is that under its influence, the body rotates at a high speed, inevitably disrupting its integrity. The results are already noticeable now. Fragments are breaking off from the asteroid's equator. After that, Newton's law of gravity immediately comes into play. forcing the fragments to orbit the celestial object. That is why, due to these processes, the asteroid 6478 Gault developed a tail made up of debris and dust. After some time, the body will completely break up into pieces, since the surface of such asteroids is quite loose. What's remarkable is that the Hubble telescope revealed these amazing stories about satellites and asteroids to us. The Moon. Apparently, the diameter of Earth's satellite is quite large, which is why the Hubble telescope can't capture it fully in its images. Other spacecraft are capable of handling this simple task, so it's not efficient to spend Hubble's time and resources photographing the Moon. In the future, it will serve more important purposes. Nevertheless, take a look at this image. Astronomers were able to capture it 9 years ago when Venus was passing in front of the Sun. In such cases, the Moon is very useful for research as it acts as a kind of mirror. It helps to detect deviations that occur as a result of the scattering of light rays passing through the atmospheric layer of Venus. This way, researchers can accurately determine which chemicals are present in the atmosphere of the object being studied. For example, we now know the composition of Venusian clouds. That is, a specific image of the Moon was taken to confirm the results of other studies. Stars that are far away from us often fall within the field of view of the Hubble telescope. When a huge star appears in front of an exoplanet, the device determines which substances fill the atmosphere of the celestial body. In light of this, a question arises: can Hubble also observe the Sun? Unfortunately, no, because its brightness is too high. However, the light reflected by Earth's satellite, the Moon, is sufficient for the aforementioned research. I wonder if Hubble has observed Saturn and its inner moons. At the moment, there are no research probes near the ringed planet, because 4 years ago the Cassini spacecraft ended its mission. Thus, it turned out that the best image of Saturn available to scientists was provided by the Hubble telescope. This planet is regularly observed, which allows us to record many processes taking place on its surface. For example, scientists now know how the weather conditions on Saturn change depending on the seasons. The Cassini probe was near the planet for 13 Earth years, which is half a year by Saturn's standards. And now Hubble is tracking the changes taking place there. The Orbital Observatory's telescope has already managed to capture a giant storm that swept across an area of several thousand kilometers. In addition, other images have also been sent to Earth. For example, several photos of impressive hurricanes on Saturn. How should we end our story? Perhaps with a description of the object P2010A2, currently designated 354P linear. Material for its study was also kindly provided by the Hubble telescope. If you look closely at the image, you can see an object with clear signs of a comet. P2010A2 was even mistakenly included in the corresponding catalog, but in fact, that's not the case. The object's nucleus does not resemble that of a comet at all. Thus, thanks to Hubble, the world learned that we are dealing with a unique phenomenon that has never been observed before: the collision of two asteroids. It was the waves from the impacts that created something resembling a cross. The rubble that makes up the surfaces of both asteroids is flying apart at tremendous speed in all directions. But then, due to weak gravity, it gradually gets pulled back toward the center of the object. The Hubble telescope has long since become one of the most important tools for exploring space. Who knows, maybe very soon we'll get even more amazing images from it. We are very glad that there are many people like you who watch, subscribe, share our episodes, and leave likes. After all, without you, none of this would exist. Most importantly, don't forget, the more you leave comments on the video, the more active you are, the more people will learn about us. And one day, they will change the world.